Hello, class. Today we're going to be talking about some basic trig ratios. Okay, trig is short for trigonometric. You don't really need to know that. These are just going to be some basic ratios. So, in right triangles, okay, there are three basic ratios that are useful. Okay, and you've seen these before, though you may not have known what they were. Okay, if you hadn't looked at a scientific calculator or a fancy calculator, you might have seen the buttons. Okay, that look like this. You have sin, cos, and tan. Okay. And really what those are, sin is short for sine, cos is short for cosine, and tan is short for tangent. And we're going to get into what those three ratios are in this video. Okay, so as we were just saying, those three ratios are simply sine, S-I-N-E. Okay, a lot of times you see that abbreviated with just SIN. Okay, and that's going to be the ratio of the side opposite an angle over the hypotenuse. Okay, so the side opposite of the hypotenuse. So if I get this triangle here, that's my right angle. This is always going to be the hypotenuse right here. Remember, the hypotenuse is always opposite the right angle. Now, the sine here is going to be dependent on which angle you're looking at. So if we're looking at this angle, well, the side opposite that is going to be this side here. Okay, if I'm looking at this angle, the side opposite is going to be this side. So it really depends on which angle you're talking about in this triangle. But this, the one that's opposite the right angle, that is always the hypotenuse. Okay, that is always the case. Second ratio you have is the cosine. Okay, you probably won't see it spelled out like this too often. Okay, usually it's going to be abbreviated COS. Okay, and that's going to be the ratio of the side adjacent. Okay, adjacent simply means it's connected to it. Okay, like if you had adjacent rooms, you'd have rooms that are connected to each other. Okay, again, over the hypotenuse, I'm going to abbreviate that HYP. So the cosine would be the side adjacent. So again, if I'm talking about this angle here, I'm going to be talking about this side over the hypotenuse. If I'm talking about this angle, it would be this side over the hypotenuse. We're going to get into some of these examples in a few minutes. Okay, our last ratio is our tangent. Okay. Okay, our tangent. Okay. And that's going to be a special one. That's going to be our side opposite. Okay, our side opposite over our side adjacent. Okay, so if I'm talking about this angle, my opposite is going to be the small one. My adjacent is going to be the longer one. If I'm talking about this angle, my opposite is going to be the longer side. My adjacent is going to be the shorter side. Okay, so those are your three basic trig ratios: the sine, the cosine, and the tangent. Okay, an easy way to remember these three things are SOHCAHTOA. No, I know it sounds like a Native American word, SOHCAHTOA, but really it's just a mnemonic device, something that you can say a lot, something that will help you remember something. And these simply mean sine, okay, is the opposite over the hypotenuse. Okay, the cosine is the adjacent over the hypotenuse. Okay? Okay, remember, I'm reading this way. Sine is the opposite over the hypotenuse. Ca is cosine adjacent over hypotenuse. And tangent is the opposite over the adjacent. Okay? So sine opposite hypotenuse. Ca cosine adjacent over hypotenuse. Toa tangent opposite over adjacent. Okay? Remember, as long as you have these, as long as you have a right triangle here, you can determine these ratios. And these often show up on our friend the SAT. Okay? Doing a lot of work to prepare those for you, prepare you for that, so you score well on it. Let's take a look at a few examples. Okay, in our first example, I want to determine the sine, cosine, and tangent for angles. Oh, I need to change this here. Angle C and angle B in the triangle below. Okay, it's got to be C and B because you can't really do this for the right angle so much. So we're going to be looking at angle C and angle B in this triangle. Well, let's get started. So first, the sine. Okay, I'm going to use the abbreviation of angle C. Okay, sine of angle C is going to be my opposite over my hypotenuse. Okay, so if I'm looking at angle C here, okay, my opposite, okay, if I go opposite that, that's going to be 5. My hypotenuse, well, the hypotenuse is always opposite the right angle. In this case, hypotenuse here is going to be 13. Okay, so the sine of angle C would be 5/13. You can go ahead and get a decimal equivalent for that if you needed to, but right now I'm just going to take the ratio, 5/13. The cosine of angle C is going to be my adjacent over my hypotenuse. Okay, so angle C right here, my adjacent is going to be 12. That's going to be 12/13. That's really close to 1 if you turn it into a decimal. So my cosine of angle C, 12/13. And my tangent for angle C is going to be my opposite over my adjacent. Okay, TOA, right? So, ka, TOA. Opposite over adjacent. The opposite we said was down here. That's 5. And my adjacent is 12. That was for angle C. I'm going to go ahead and change colors here to do angle B. Okay, so for angle B is down here. We're going to use this funky green color here. Angle B, the hypotenuse stays the same. Okay, but now for angle B, this becomes my opposite, and this becomes my adjacent. Okay, so sine of angle B is going to be my, again, my opposite over my hypotenuse. Okay, but because I'm talking about the other angle, my opposite is 12. My hypotenuse is still 13. Hypotenuse is always opposite your right angle. Cosine B. Okay, that's going to be my adjacent. So ka adjacent over my hypotenuse. Adjacent here is going to be 5. And again, my hypotenuse is 13. And my tangent of angle B. Okay, tan B is going to be opposite over adjacent. Okay, OA, SOHCAHTOA, TOA. Okay, so my opposite is 12, and my adjacent is 5. Okay, as long as you know which angle you're talking about, just make sure you're setting it up properly. Hypotenuse is always opposite the right angle, opposite, adjacent. If I'm talking about side C, this is now opposite, this is adjacent. Just depends on which angle you're looking at. Okay, example. And I took these two examples directly from Delta Math. So if you follow along here, you should be able to finish off your Delta Math assignments after this. While we're here, I'm going to let you know that the magic word for this video is tissue, Tissue. Tissue. Okay, so triangle, LMN. Okay. So I got my right triangle here, not a very good job, but I know that angle N is 90. Okay, so that's my 90-degree angle. I've got N, I've got M, and I've got L. Now let's fill in the other things we know. LN is 33, so LN, this is 33. NM is 56. This is 56. Okay, I could find ML using the Pythagorean theorem. Oh, here it is, 65. They gave it to us. Don't have to do the hard work. They gave it to you right there. And now they're looking for what is the tangent of L. They're talking about this angle right here. The tangent of angle L is going to be OA, SOHCAHTOA. It's my opposite over my adjacent. Okay. In this case, the opposite is 56. My adjacent is 33. Okay, this is the one that's adjacent to L. Okay, and it's looking for the nearest hundredth. Okay, so you plug that into a calculator. That's going to be about 1.70. I think it's 1.696, something like that. Okay, but where they're looking to the nearest hundredth, that should be sufficient. Okay, let's take a look at one more example. Okay, last example here. In triangle TUV, the measure of angle V is 90, VU is 12, TV is 5, and UT is 13. And wants to know the ratio of tangent T. So, draw my triangle here. Okay. I'm going to call that my 90-degree angle. If that's my 90-degree angle, that's going to be V. I also have U, and I have T. So, VU is 12. VU, 12. TV is 5. TV is 5. UT, 13. Okay, that's the old 5, 12, 13 Pythagorean triple. We've seen that a couple times. It wants to know what ratio represents the tangent of T. Okay, so right here again, and again, tangent of T is going to be the opposite over the adjacent. Okay, TOA. So the opposite here is 12. The adjacent is 5. And because looking for the ratio, I'm going to go ahead and leave it just like this. Now let's say they had asked for, I don't know, let's say cosine of u. Okay, well, a cosine of u, I've got my u right here. Okay, there's u. Okay, cosine, so ca, that's my adjacent over the hypotenuse. So the cosine of u, if I'm looking for that ratio, opposite over hypotenuse, sorry, adjacent over hypotenuse, forgive me. So ca, that would be 12 over 13. Okay. Now, if they wanted that as, if they wanted that as an actual value, you simply go 12 divided by 13, and you would get 0.923. Okay. It's about 0.923. Okay. Hope you're listening carefully for the magic word. If you have any questions, go ahead and see me in class. Thank you.